All right, example 7 of section 6, we're going to write and solve a rational inequality. So we have Jamelia who runs an online store selling costume hats, and she spends $378 on an embroidery machine. In addition, it costs Jamelia 1.85 to make each hat. So however many hats we make, so maybe we can make that a variable x, right? How many hats will Jamelia have to make so that the average cost per hat, so the average cost per hat is less than, so it's less than or equal to $5. So we want to figure out how much Jamalia can spend here, make sure it's equal to $5. How many hats, her average cost per hat, right? So here what we want to do is we want to write an inequality and identify the excluded values. So we're going to fraction, set our denominators equal to 0, then we'll solve it and divide it into two intervals and then see which ones come true. Okay, so we know that the cost, right? We want to find the average cost per hat, right? So that is cost per hat, right? So the cost that it takes to make the hats divided by per hat, right? So each hat. Okay, we're going to let each hat represent x, and we want that to be less than or equal to 5, right? So how much does it cost to make the hats? Well, it costs the embroidery machine, right? It costs to have the embroidery machine, and then in addition, plus, it costs $185 each hat. So just the cost is our $378 plus the cost per hat, right? 1.85 per hat x. And then how much hats do we make? Well, we don't know. That's why we're going to use x. So then we have this inequality is 1.85x plus 378 over how many hats we make, and we want that to be less than or equal to 5, and so we want to solve for x here. Okay, so now just solving this, we just set this equal to 0, so can't have that, right? We don't want to sell 0 hats, right? So we're going to put that on a number line, 0, let's just put it right in the middle, 0, we're going to test to the left or to the right. Okay, but now we need to solve this, so how do we get rid of dividing by x? We multiply by x. So we get 5x is, we can just treat this as an equal sign, right? That's why we're testing on a number line. 1.85x plus 378. We can minus 1.85x. So we minus 1.85x, 1.85x. That's almost 2, right? So that's 3.15x equals 378. So I'm going to take 378, and divide that by 315. And 3.15 equals 120. So about 120, so we'll put 120 right here. And now we're going to test, right? We can't have negative hats, right? X can't have that to be negative, right? So that's not going to matter. So how about, is our answer somewhere in between here or somewhere after here? Okay, so we test in between. So we can test, say, 130. So we plug in 130, so 1.85 times 130 plus 378 divided by 130, and we're going to see, is that less than or equal to 5? Okay, so we go ahead and do that. We take 1.85, we times it by 130, and we add 378 equals, then we divide that by 130, and we get 4.75. 4.7576. We'll go with that. Okay. Is that less than or equal to 5? That is true. So we're probably looking at answers above that. Let's test in between. How about 1? So 1.85 times 1 plus 378 over 1 less than or equal to 5. So really I'm just taking 378, correct? 378 plus 1.85, that's 379.85. Is that less than or equal to 5? Nope, that's not true. So our answers need to be at 120 and above, right? We're probably not going to make infinity, but It can be 120 because our or equal to, so that's why there's a bracket here. So we want our hats, number of hats, to be greater than 120. So you can just say number of hats needs to be 120 or greater. Okay, and there we go.